in the recovery room, we gave them a bunch of memory tests. Now, these patients had all volunteered for this. They gave informed consent. They knew what was happening. They didn't have anything else to do during surgery. They were quite happy to listen to our silly little tape. And again, this is a comparison of memory for recall or recognition for words that they actually were presented during surgery, and then control list of words. And you can see there's no cued recall on the part of these patients at all, nor any recognition. But when we gave them a free association test of priming, where we said, okay, ocean, what's the first word that comes to mind? These patients were much more likely to give the word that had actually been paired with ocean than in a control condition. So here we could show that, as expected, general anesthesia abolishes explicit memory, but it turns out that there is still some the priming effect, so that at least under some circumstances it doesn't abolish implicit memory. There's still some unconscious memory, some priming there. This has now been confirmed a bunch of times. A lot depends on what anesthetic agent you do. When we repeated the same experiment with a different anesthetic agent, we didn't get it. But enough other laboratories have gotten this kind of result that we can now say pretty much for sure that at least under some circumstances, some anesthetic agents spare implicit memory, even though all anesthetic agents, almost by definition, impair explicit memory. All right. Okay. Which raises another question, which is, okay, if you still get, the anesthesiologist didn't always like this result because he says, oh, we don't want any memory at all, right? We just don't want any memory, period. So this study initially raised the question about whether maybe anesthetized patients are aware during surgery after all. Okay, this is entirely possible. We know that there are other circumstances where patients are aware during surgery but don't have any conscious recollection of it afterward. The commonest case of that is outpatient surgery, which is often done with massive doses of barbiturate or benzodiazepine anesthetic, where you're awake and you're able to interact with the surgical team during the surgery, but you don't remember any of it afterwards. And it's possible that that's what happens in general anesthesia as well. It's possible, but it turns out not to be the case. British anesthesiologist named Tunstall demonstrated this beautifully using what he called the isolated forearm technique. This was a series of studies, again employing balanced anesthesia, where there's an anesthetic agent given and a muscle relaxant. Remember, the muscle relaxant is basically a curare-like drug that flows through the bloodstream and then binds to various receptors. And what Tunstall did was to put a blood pressure cuff on his patients and inflate it to prevent the flow of blood to one forearm. So what he did essentially was to isolate the forearm from the effects of the muscle relaxant, which would allow, in principle, patients to actually use the isolated arm to communicate with the anesthesiologist. It was really a brilliant idea. Here's a representative study here of awareness in women undergoing cesarean section as the anesthetic agent is being delivered. The forearm has been isolated so that the hand is not paralyzed, and the patient is simply asked, if you can hear me, raise your hand or lift your finger or flick your finger or whatever. And what you can see is that in the very early minutes of the procedure, there is some response on the part of the patient, but 2 minutes in to the procedure, response has dropped essentially to zero. This is an index that a patient who appears to be adequately anesthetized really is adequately anesthetized. Even though they can respond, they don't respond to these various kinds of commands. So in anesthesia, you have an example of an alteration in consciousness that basically is intended to abolish consciousness by chemical means. And the issue in anesthesia is not just how it works, that's a mystery, but the other issue is whether it actually works and how would we know. That is the same old problem we've always had, which is how do you get an objective, public, scientific measurement of a subjective, private, personal state. And in anesthesiology, as, for example, as was the case in coma, we seem to have worked that out pretty well. We have a bunch of behavioral, autonomic, and central nervous system correlates that help us to determine whether a patient is actually conscious or not. So I offer both coma and anesthesia to you as examples of how we can go about solving the problem of measuring a person's state of consciousness objectively. How awake are they, and how aware are they? Okay, we'll take up this problem again in a somewhat different form next week when we talk about problem of sleep and dreams. Thank you very much. Everybody have a good weekend. We'll see you on Monday. Well, yeah, we'll see you on Monday.